Welcome to the 28th lecture on probability and statistics, and we will keep on studying more about probability in this lecture. In this lecture, we'll talk about independence of events and the conditional probability. Events A and B are independent if the occurrence of A is not influenced by the occurrence of event. The occurrence of B is not influenced by occurrence of A or vice versa. A very simple example of two independent events is if we roll two dice, die 1 and die 2. They are tossed together. What is the probability that we get a 2 on die 1? This is defined as event A, whereas event B is a 6 on die 2. Right. So since these two events are independent, the probability of appearing a 2 on dice 1 is 1 over 6, and the probability of appearing a 6 on die 2 is also 1 over 6. So these two events are independent because rolling die 1 is not influenced by rolling die 2 or vice versa. So these two events, since their occurrence is not mutually affecting each other, occurrence of one event isn't affecting the occurrence of another event. Therefore, these two events are independent. There are dependent events for which we will solve an example at the end of this lecture. Right. So if A and B are independent, the joint probability, which is also written as A intersection B, can be written as probability of A times probability of B. So the joint probability of A and B can also be written as the probability of A, computing separately the marginal probability of A times the marginal probability of B. But what is this formula otherwise? If A and B are not independent, then the formula for this formula involves another term that we call conditional probability. Probability of A B is probability of A times probability of B given A, or we can write B first, probability of B times probability of A given B then. Whereas A given B or B given A, these two terms are conditional probability terms. They are read as, for example, A given probability of A given B is read as probability of A given B. What does this physically mean? Is the probability of A's occurrence when B is definitely occurring. The event B is definitely happening. What is the probability that A will be happening at the same time, right? So how would you this, and probability of B given A, this one, what would physically this probability mean? That probability of occurring B when A is definitely happening. So for A, we are sure that A is happening, but we have to find out the probability that B is happening at the same time too. Right. To further understand these two events and to check whether two given events are independent or not, we will solve a simple example involving this table. The table has two rows and two columns. In row number 1, we have colorblind, we call it event A. In row number 2, we are having people who are not colorblind. A is complement. In column 1, we have men. In column B, we have women. So these four terms, probability terms that I have mentioned in this table, are joint probability terms like we did in our last lecture. This is probability that a person is a man as well as a colorblind. It's 0.04. Joint probability table. Which one? This one. This whole is the joint probability table. Right. So what is probability of AB? The person is a man as well as he or she, or he is a color, as well as he is a colorblind, is 0.04. What is the probability that the person is a woman and she is a colorblind? A, comma, B, C. Probability of A, B is complement, read as probability of A, B is complement, or probability of A intersection B's complement. It's given the table 0.002, and we can figure out all the remaining two probabilities. Probability that a man as well as he is not colorblind is 0.47. Probability that the person is a woman and she is not colorblind is 0.488. Right. Next we talk about conditional probability. Let's compute conditional probability given this joint probability. We have studied earlier that if we do not know that whether two events are independent or not, we'll use the general formula. What's that? Probability of AB is probability of A times probability of B given A. We studied this on the last slide. Probability of AB is probability of A times probability of B given A, or the second formula. These two formulas will give us the same result. Right, so probability of AB is probability of A times probability of B given A. So how do you find probability of B given A? It's probability of AB dividing this by probability of A. This one, dividing this left hand side by probability of A, and the right hand side as well, which will cancel this probability of A term. So probability of B given A is this, probability of AB divided by probability of A. And we know that probability of A is marginal probability. We studied marginal probabilities in our last lecture. How can we compute probability of A? This is probability of AB plus probability of ABC. The sum of this row we studied in last lecture. So plugging these values in gives us probability of A, and then dividing this would give us probability of B given A is 0.95. What does this physically mean? This means that the probability of a person's being a man, since this is given A, this means something is definitely there, means A is definitely there. What is A? A is the colorblind, that the person is a colorblind. It's definitely there because we are having this A term after this given sign. Probability of B, what is B? B is a man. Given that he or she is a colorblind, what is the probability that he or she is a man? That the person is a man. So this is the probability of persons being a man, given that he or she is a colorblind. Right, so the person is a colorblind. The probability of his or her being a colorblind is quite high, 0.95. Why is it quite high? Because the colorblind is a male oriented or a male dominant disease, therefore it's high in men. You can compute the probability of B complement given A. It's a homework for you. You have to compute this probability. Probability of B's complement means that the probability that the person is a female given that the person is colorblind. You will get a very small value for this because the colorblind, this disease being colorblind, is a male dominant disease. It's found in male much larger than it is found in women. So it's a male dominant disease. Therefore, probability of B given A would give us a very high result, a result that is very close to 1, whereas the probability of B's complement given A will give you a smaller result. You have to compute this as a homework. Right. And then the last thing for this lecture is checking independence. We studied earlier in this lecture that probability of AB or probability of A intersection B is probability of A times probability of B only if A and B are independent. So if we are given two events, we can compute their joint probability and then their marginal probability, and then we can compare the left hand and the right hand sides. And if they are equal, they are independent. If they aren't equal, they are not independent. Let's put this check on this example. We are solving this example, this colorblind example. So Probability of a person's being a man, no, this one, A and B are independent if probability of AB is probability of A times probability of B. We studied this earlier in this lecture. So probability of AB can be straight away taken from the table. We don't have to compute that. Probability of AB is 0.04 given in the table, luckily. So probability of A is the marginal probability obtained by summing this row, whereas probability of B can be computed by summing this column. So summing first row, summing first column. Summing first row gives us probability of A, marginal probability of A. Summing first column gives us the marginal probability of event B. So we'll multiply these two, this one and this one, the two marginal probabilities. The answer is 0.021. And what is the joint probability taken from the table? Is 0.04. So 0.04 is not equal to 0.021. Therefore, A and B are not independent. So in this lecture, we have studied about independence and conditional probabilities, and we have solved two examples where two events are independent, and in the second example, we figured out that A and B, the two events, are not independent. So that's all for this lecture. We'll continue studying more about basic probability terms in our upcoming lectures. Thank you.